Hi everybody, it's Miss Saltstein. This section is all going to be word problems, but spoiler, they are all division word problems. So the lesson 10 is called Applications of Dividing. That means dividing in the real world. So in this one we have a bird, and it says a bird is flying at an average altitude of 10 meters above the ground. After 3 seconds, it settles on a branch that is 3 meters above the ground. Interpret the quotient to describe the rate of change in the bird's altitude. Give your answer to the nearest hundredth, and remember that the bird is descending. There are a lot of words in this problem, and these are the ones that stand out to me. So we've got the quotient, okay? And we've got this word interpret, okay? So quotient means the answer to the division problem. So we're going to interpret the answer. Interpret means to say what it means, okay? An interpreter says what somebody has said in another language. They said, oh, they said this, and they say it in your language. So you're gonna translate this number into, just regular language. That's how we interpret it. To describe the rate of change in the bird's altitude. Give your answer to the nearest hundredth. Okay, that's important. So rate of change. The rates of change that we think about all the time are miles per hour. How fast are we going? Okay. Remember that the bird is descending. Okay, descending, that means we're going down. Okay, so quotient means answer to a division problem. Interpret means say what something means. Nearest hundredth, the hundredths place is right here. Okay, where the 1 is. All right, so now we've thought about the words in the problem that we're jumping out. And now we're going to draw a picture. Okay, we're going to start by drawing a bird. And then it is about 10 meters above the ground, so I'm just going to label that. Let me draw the ground. All right, so there's the bird. After 3 seconds, it settles on a branch. Oh, there's a branch. So I'm going to have to draw a tree. And, okay, here's the tree. And the bird is going to settle on a branch of the tree. And that branch is 3 meters above the ground. All right, so now the rate of change, what's changing here? Let me draw kind of the path of the bird. The bird is gonna kind of fly and get lower and lower until it lands on this branch. So what is the rate of change? Well, what's changing here? Okay, there are 2 things that are changing here. Okay. Are the altitude, that's the height. This altitude means height. It goes from 10 down to 3. Okay, so that is a decrease of 7 meters. All right, what else is changing? Time. Time is changing. So basically, for the bird to fly down, it takes him from start to end 3 seconds. Okay, so I can say a decrease of 7 meters per 3 seconds. Now, if you put that in, you're going to be wrong, okay? Because they're asking for the rate of change, and what they actually want here is the unit rate. Okay, if you're going, if you go 10 miles in 30 minutes, you don't tell somebody I went 10 miles in 30 minutes. You tell them I went 20 miles per hour. Okay, so we want the unit rate. We've got 7 meters per 3 seconds. So what I'm going to do here is 7 divided by 3. Okay, let me rock a little long division over here. Going to annex a 0, bring it down. Uh-oh, it's repeating. 3 times 3 is 9 again. Remainder is going to be 1 again. Annex another 0. Okay, and I'm in an infinitely repeating loop here that's going to keep going. Okay, now I'm going to need to do what it said right here. Give my answer to the nearest hundredth. Okay, so I talked about rounding in a previous video. Let me just grab the chart that I had for it, which I think is right above here. Yeah, so when rounding decimals, mark your place. Okay, we're going to round to the hundredths place, so we're going to be in that same spot. Look next door, 5 or more, raise the score. Okay, let me do that. So mark my place. I'm rounding to the hundredths place because that's what it said to do in the problem. Look next door. There's a 3 next door. 5 or more, raise the score. Not going to do that. Okay. 4 or less, let it rest. So I'm going to let it rest at 3. Okay. And this is going to be my answer, 2.33. Let me go back to the problem. So 2.33. But wait! When they say remember, they're giving you a hint. Remember that the bird is descending, which meant going down. So you're going to need to put a negative in front of the 2.33. Okay? And they've already given you the meters per second. So that one is good to go. Let's do the next one. These are from your practice, by the way. And then there's a quick check one below this one. This one is pretty much the same. I just wanted to point out to you that in this one, they have already written the negative in front of the problem. Okay. So solve using division of rational numbers. If a car's value decreases by 250,000 in the first 6 months, how much does the value decrease per month? Okay, so money per month. You're going to take 2,500. You're going to divide by 6. Oops, I just made that car a lot more valuable than it was. 2,500, not 25,000. All right, I'm going to divide by 6. 6 doesn't go into 2, it does go into 25. 4 times. Bring down a 0. 6 goes into 10 one time. Bring down a 0. 6 goes into 40. 6 times 6, I think, is 36. Okay, add the decimal here. Annex a 0. 6 goes into 40, and I'm going to do this a little longer than I did the last time. It is repeating, but this is money, so I want to at least round to the nearest cent. Oh shoot, I missed a step here, didn't I? No, that's this 0 here. Whew. Okay, 6 times 6 is 36. Bring down the 0. 6 times 6 again. So far we have $416.66. 36. Annex of 0. This 0 is going to be for rounding. Okay. All right. So I'm not gonna annex another 0. I just did that so I could round. So remember, identify, mark the place. Okay. Look next door. 5 or more, raise the score. So I'm going to raise this, and I'm going to say this is $416.67. Raise it up. Okay? So I'm not going to put the negative because it's already there. 416.67. That's my answer for that one. All right. So in this one, big takeaways are that just pay attention. If they put the negative here, don't put it again in the box. Okay. And then in this problem, we had to round up because when we looked next door, it was 5 or more. Okay, this one's from your quick check. A squirrel has stored acorns in a hole that is 45 feet from the ground in a tall tree. The squirrel starts on a perch 100 feet above the ground. The squirrel moves from the perch down to its stored acorns in 5.25 seconds. Interpret the quotient to describe the rate of change in the squirrel's height above the ground. Give your answer to the nearest hundredth. Okay, let's talk about the words first. Interpret. So that's what we're asked to do here, is just say what it means. Quotient. Quotient is the answer to a division problem. Describe the rate of change. And we're actually going to use the unit rate because if you look here, all of these are in feet per second. So this rate of change is going to be our unit rate. That's the rate per 1, like miles per 1 hour. Give your answer to the nearest hundredth. All right, I think I'm ready to draw my picture now. I'm going to draw a tree. Here's the squirrel. He's up on a perch. Oh, how do we draw a squirrel? Oh, this is the worst drawing of the squirrel, like, ever. Let me at least give it an eye, then maybe it'll... It looks like a dinosaur with a bushy tail. Anyway, pretend that looks like a squirrel. Okay, and then this is the little hole where the squirrel keeps its acorns. Oh, that was a good acorn, you guys. Look at that, okay? The squirrel's bad, but I made up for it. See, the acorn looks like an acorn. Or a brown strawberry. Okay, so the squirrel stored the acorns 45 feet above the ground. So this is 45 feet. And then he's starting at a perch that is 100 feet above the ground. Okay. And then this journey is going to take him 5.25 seconds. All right. So now that I'm looking at my picture and I'm trying to figure out how fast he went, I think I need to go how far he went, because these are all in feet per second. And so first thing I need to do is how many feet did he actually go in 5.25 seconds? I don't know. Okay, so let me figure that out. How far was that? Well, if I started at 100 and I ended at 45, I think I'm going to subtract to find the difference in his elevation, the change in elevation. How different is it from 100 feet to go down to 45 feet? And 9, 10. No, 5. 10 minus 5 is 5. All right. 9 minus 4 is also 5. All right. So that journey was 55 feet. Per 5.25 seconds. Now here's the deal. I want this to be per 1 second. And remember that with fractions, you are allowed to divide the denominator as long as you also divide the numerator by the same number. Okay, so I'm going to divide by 5.25 because 5.25 divided by 5.25 is 1, and that's what I want. 55 divided by 5.25, I'm going to grab a calculator for that. 55 divided by 5.25. Oof, yikes, look at that number. We're going to round this number. Oh, that's funny, it came out really tiny. Let me make it bigger. Okay, so this is the number of feet the squirrel's going in 1 second. It says right here in the problem, let's go back up here to the problem. It says to round to the nearest hundredth. So I'm going to mark the hundredths place. That's the 7. I'm going to look next door. The 6 is next door. Is it 5 or more? Yes. Okay, so raise the score. I'm going to raise the 7 up to an 8. Okay, so if I raise it up to an 8, I get 10.48, and that is in meters per 1 second. All right, so these two answers are out of the running. They've got 19. Now, is it positive or negative? Well, what I want to think about here is, did the squirrel move up or down? So we're going to call this down, and that will be a negative distance. Okay, let's just read the answer and make sure it makes sense. The quotient that describes the rate of change in the squirrel's height above the ground is negative 10.48 feet per second. Looks good to me. Okay, so I'm going to add that negative right there. All right, guys, good luck with the word problems. Don't forget to draw a picture. It really helps.